In this section, I'm going to be talking about data cleansing. Now, what is data cleansing? Well, let's try to explain a few terms. When you receive data frequently, you'll receive it in a dirty state. It's raw and not ready for data mining. That's when data preparation becomes front and center and very important. It's imperative to determine what data is available to analyze and transform. So there are ways to clean and pre-process data, which include dimensionality reduction, handling missing data, feature scaling, and dealing with outliers. Now, with dimensionality reduction, when dealing with high dimensional data, it is often useful to reduce the dimensionality by projecting the data to a lower dimensional subspace, which captures the essence of the data. This is called dimensionality reduction. Now, this is a quote from Machine Learning, a Probabilistic Perspective in 2012. Now, what does that really? Well, it's a process of reducing the dimensions of your feature set. Now, a feature set could be data set with hundreds of columns, sometimes even thousands of columns. I've seen data sets that consume data from 1600 sensors. Dimensionality reduction is bringing the number of columns down. For example, let's say you have a array of points for a sphere in three-dimensional space. Well, you can convert that sphere into a circle in two-dimensional space. That's dimensionality reduction in a few words. Dimensionality reduction is bringing the number of columns down. Now, the next part is handling missing data. How do you handle missing data? Well, too often, if you have missing data, then your outcomes will be invalid, or more than likely, it's going to cause errors in your machine learning routines. There is a term that you probably have heard before, is that when missing data, when it's dropped, it is imputed. Data commonly has observations with missing values for one or more features. Now, you would say, well, why are values missing? Well, maybe missing due to manual data entry or equipment errors or web forms that did not have any type of validation when it comes to missing or complete data. Common ways of handling missing data include discarding observations and imputation. Now, of course, discarding observations with too many missing values may be reasonable if it's only a few rows that are discarded. So if you're discarding 50 rows out of 1,000, well, that's more than likely appropriate, right? It's 5%. But discarding 50%, so if you have 1,000 rows and you're discarding 500, well, of course, that would not be. This takes us to feature scaling. Now, with feature scaling, it's a method used to normalize a range of independent variables or features of data. So I want to focus on the word normalization. Well, it's a scaling technique in which values are rescaled to end up ranging from, let's say, 0 to 1. That's also known as min-max scaling. There are also other scaling techniques, such as standardization, where the values are centered around a mean and a standard deviation, whereby the mean of that attribute becomes 0 and the distribution has a unit standard deviation. Now, last but not least, the last part is dealing with outliers. Outliers should be identified and examined if they are valid. Sometimes removing these outliers is a good idea, but in some other times it may not be, especially if they are edge or corner cases. Now, really briefly, edge cases is when an issue occurs at an extreme minimum or maximum. And then corner cases is when multiple parameters are simultaneously set at excessive levels. Now, of course, close examination of outliers is essential, since outliers can indicate possible erroneous data. So, for example, if you're looking at the stock price of Apple or Tesla or Google or Amazon, and then all of a sudden you have a stock price of 0 in a time series plot, well, in that case, that's an outlier that can be safely removed. On the other hand, when a stereo speaker distorts audio when it's played at a maximum volume, in that edge case, that outlier is significant and cannot be ignored. Therefore, data preparation is crucial to produce valid and reliable models that have high accuracy and efficiency. Excellent quality data will lead to more useful insights and will enhance, ultimately, the organizational decision making and improve overall operational efficiency. Now let's try to handle missing values with an example. we're going to be using pandas fill NA and pandas drop NA when it comes to discarding observations and imputation. So pandas frame drop NA function removes rows with missing data from a data frame. And when it comes to imputation, the data frame dot fill NA function replaces a missing value by either a specified value resulting from a method. So I'm going to go ahead and copy and paste a fictitious data set for a couple games whereby, let's say, each game has a rating and a number of installs. All right, so over here, I created a data frame with a couple of games that are from Google Play Store, but I created all. So I'm going to go ahead and run. And right off the bat, you can see there's Garena Free Fire, Mobile Legends, Brawl Stars, and a game with an unknown title, game rank, installs, average rating, and growth. Those are the columns that we are going to be working with. Now, if you wanted to drop all the rows where at least one element is missing, so in this case, I would use my drop NA function. Therefore, if I go ahead and type df.drop_na, now what this is going to do is going to remove all the rows with at least one element missing. So in this case, it's going to drop this row, and this row. And it's only going to leave me Mobile Legends, bang, bang. All right, perfect. Now, if I wanted to be a little bit more targeted and define which columns to look for those missing values. In this case, for example, if I want to look for columns with missing values, in this case title and average rating, then I can write the following. Now in this case, what's going to happen is anywhere where there's a row with missing data in the column title or average rating, that row is going to be dropped. So in this case, what's going to remain is Garena, Free Fire, the Cobra, and Mobile Legends Bang Bang. Let's give it a shot. Sure enough. So over here, to repeat, I drop the rows with missing values in the title column and the average rating column. So this is going to be dropped over here, and in the average rating, this is going to be dropped, and this is going to be dropped. So the remaining ones would be Garena Free Fire and Mobile Legends. Pretty straightforward. Now the next part that I want to talk about is imputation. Now imputation is the estimation of missing values with a lot of times descriptive stats or predictive values. So again, I'm just going to list my initial data frame that I'll be working with. And now if I wanted to replace all my missing values with a 0, then I can type the following. Excellent. As you can see here, this value became a 0. These two values over here became a 0. Now this is probably one of my favorites. If I wanted to propagate non-null values forward or backward, I can type the following. So what's going to happen is the average rating column, I am going to propagate in a forward direction the value 4.24 for my null values. As you can see here, 4.33, 4.24, 4.24, 4.24. Excellent. So again, you can forward or backward propagate. So the next section, if I wanted to replace all the missing elements in the column, let's say title, with text that says no title available, I can write the following. And as you can see here, we have the movies Garena, Mobile Legends, Brawl Stars, and the last one would be no title available. If I want to make this look a little prettier, I can write the following. And as you can see here, instead of the value 0, you have no title available. Now, in the last part, if I wanted to use a function that replaces each game rank that's missing a value by the maximum of all the values in the corresponding column. So in this case, if I wanted to replace my missing values here with a game rank of 100, I can write the following. As you can see here, these are my null values over here. So if we look at the original game rank, we had a null value here and a null value here. So it's 100, 7, 100, and 100. 100, 7, 100, and 100. So again, this function replaced each game rank with a missing value by the max of the corresponding column. Very cool. This completes our section on data cleansing and how to handle missing values.